Hello everyone. Um, I would like to talk about the review final exam for problem number one. Let me see if I can cut this one. Let's see. Oh, hmm. I cut it. Okay, that's okay. Um, let's start with problem A. What a sequence. All right. What is a sequence? So you guys should know that a sequence is, I'm gonna just say in my own word, right? A list of number, right? A list of number. Um, so if I want to talk about a conversion sequence, conversion is in sequence. Um, let's say AN will be something like something in the set as one one half, one third, and so on up to one over here. So as you know that's in order to know if the, the sequence is converse or diverse, you guys just need to take limit of the last of the I mean of the general form. And this and this one, you know that as and go bigger and bigger, this guy gonna be get to zero. So this converse. Um, for diverse guy, diversion sequence, um, as a BN, you can just go with something go, up to infinity or something like that. So just that is is you can write in general form as n, right? Uh, so for a B, what is a series? Series, I will say, um, is a sum of all number in sequence. So, for example, if I keep working with an over here, uh, it's gonna be add all this number together to get series, right? Um, so um, give an example of conversion one. So let's say um, the series um, Cn for n from 1 to infinity, that's Cn right now is, let's say, 1 over n squared. Why I go with this guy? Because this is conversion, because it is it is a p series with the p right now equal to 2, which is greater than 1. That might converge. So you can use any other series that you for sure it is converse. But I would suggest using P series going to be the easiest one, right? You can go with like 1 over n q, 1 over n 4, something the power greater than 1. That's going to be great. And for the one who diversion, I will use the an and from 1 to infinity. Remember, I use an right now is this guy. We're gonna be 1 over n. For sequence, it was a convergence sequence, right? But but for series, this guy will be diverse, divergent. Why? Because this also a p series with p right now is 1. That is less than or equal to 1, and clearly this will be diverse. It according to p series test or according to the integral test. You should know that, right? Okay. Um, so that is part B, right? For part C, they say this sequence, right? Converse or diverse. Since this is a sequence, you just need to do the limit to know if it is converse or diverse. Okay, so this is sequence. Uh, Sequence. All right. AM. So check the limit an for n go to infinity. Week right now going to be the limit of n plus 1 over squared n squared plus 3 for n go to infinity. That's give us, and you can do like sorry, let's have limit. You can use the n behavior from pre-calculus if you like. If or from calculus 2 calculus 1, you can do let's just divide by the highest power term in the numerators, sorry, denominators. So you're gonna have like everything divided by n squared right now. And you know that for this case, you should have the 1, the constant divided by variables. We'll get to zeros in n, go to infinity, we'll make all those become 0. All right, so the top there, now the top will be 1 over n I mean, you should know that later on it's will be also going to be 0 since n go to infinity. And the bottom is 1, so it's going to be equal 0. So since the limit of sequence an uh, equals 0, so that's telling us the sequence converse. Okay, sequence converse. Does that make sense? All right, so that's how you gonna say how we're gonna do to prove a sequence convert reverse. Now let's move to part D, right? D. Um, so Sn equal to what? Summation of n k equal to 1 k plus 1 divided by k squared plus 3. Okay. So this is a sequence that's gonna be the value um, of of this series, right? So sequence right now will have like three three terms that release at S1, S2, S3. We need to find those. So if I'm gonna go ahead and say S1, that means I'm gonna change all the n to be 1. Right? So k equal to 1, 1, k plus 1, okay, square plus 3. That's give us now I'm gonna input 1 into k. Gonna be 1 plus 1 over 1 square plus 3. That's give us 2 over 4, which is 1/2. So I'm gonna write over here S1 equal to 1/2. Okay, hopefully I didn't make any mistake. Um, okay, so now for F2, what you do is you replace all the n to be 2. Right, so I have k plus 1 and k squared plus 3. Which you can now replace the k to be 2 term, one term with 1 and another one with 2. So going to be 1 plus 1 over 1 squared plus 3 plus with why I did it 2 plus 1 over 2 squared plus 3. So you can see what happened in here is this guy actually is our S1, right? So S1 is here, which is 1/2, adding with the new guy. Okay, so I'm gonna go ahead and rewrite it at 1/2 plus um 3 over 4 plus 3 gonna be 7. So this will be equal to say 1 times 7 is 7 plus 3 times 2 is 6. So then 2 times 7 down at the bottom here. We're gonna be 7 plus 6 equal to 13 divided by 14. So we know that at 2 now will be 13 over 14. And lastly, for the S number 3, I do the same thing with K from 1, 2, 3, and then K plus 1 over K squared plus 3. You're gonna have, oh, sorry, plus 1 plus 1 over 1 square plus 3, and then plus 2 plus 1 over 2 square plus 3, plus 3 plus 1 over 3 square plus 3. And you can notice that these two guys actually is at 2. Okay? So I will go ahead and just use at 2 values, which is 13 over 14. At with this guy gonna be 4 out of 9 plus 3 gonna be 12. Okay, so use the calculators. You should get 53 out of 42 here. So then now your the SN will be the list of 1, 2, 1/2, and 13, 14, and 53 over 42. Okay. Actually, I should not just stop at there because it's supposed to be more, right? It's supposed to be more. So that is my D. And I will go ahead and move to E. For E, it's just ask us about does this sequence converse, right? I will come back with the practice again. I'm gonna go ahead and screenshot this guy to make my convenience. Okay. So smooth out here. All right. So and you see that we are checking if the sequence converts or diverse. So you what you need to do is just take the limit on it. Right. Limit of n. We're gonna be limit of -1 n plus 1 2 minus n over n squared plus 9 for n go to infinity. Um, and because there is a negative here, if you remember, there's like a theorem for the um, absolute value, um, uh, absolute value for the alternative uh, sequence. Mm, when I can find the limit if it equals to zeros, then I don't then the limit of an without absolute value is still going to be zero. So the reason is if you leave the -1 power n plus 1 to be another limit multiply with limit of 2 minus n over n squared plus 9 here. And if you prove that this guy becomes 0, then you don't care about the left-hand side here, right? Because the left side can be just -1 or 1, something like that. Um, and if you use calculus or pre-calculus for this part over here, you should know it's supposed to be equal 0, because let me just do that here. You're gonna do divide by n squared for all the term be 1, and n squared over n squared plus 9 squared for n goes to infinity. And you should know that all of this, right, this guy become 0. This guy also becomes 0 because the degree at the bottom was higher. This guy becomes number 1. This guy becomes 0. So you will end up with a limit of -1 to the power n plus 1 time with 0. So I don't care about the -1 over n plus 1 anymore. It's must be equal to 0. And that's converse. Okay. So that means the sequence and converse. So this is our problem 1. I'm gonna stop this videos here for moving to the other column and make it short for each column. Okay. See you guys in the next columns.